Okay, so I just created a Flutter app skeleton, or you could call it a brick, a Mason brick, which helps you generate a Flutter app skeleton with a modular structure and also follows clean architecture. This brick essentially aids you in getting started more quickly when you want to create a new Flutter project, so you don't have to build it from scratch. And it also already includes everything you need from the main app, widget book app, dependency injection, routine translation, and more. And in this video, I will try to demonstrate to you how this brick works. So I create this brick using Mason. If you're curious about Mason, you can check out their documentation at brickhub.dev. Here is the list of my bricks that are available locally on my device. This is the brick that we will demonstrate in this video. I call it modular clean app. And to use a brick using Mason, you can call it like this: Mason make, and then followed by the name of the brick you want to use. And then you can add more option. In here I add a -o option, which to define the output directory of the brick. I will set it to a Lontara, and then when we run this command, it will ask for the name of the app. By default it uses dash. In this case I will set it to Lontara, and then it will ask for the name of the organization, which will be used as the bundle ID of your app. And then it will also ask for the domain. By default it's set to com. So in this case the bundle ID will be com.banwacoder.lontara. Okay, we can press enter and off we go. Essentially, the first thing it does is create the main app project, and then it will update the bundle ID using change app package name package, and also update the name of the app using rename package. And it will also generate the launcher icons and native splash screen for the app using the default assets that I have provided. Okay, here we can see it updates the bundle ID, rename the package name, and then generate the launcher icon, splash screen. And then after it's finishing upgrading the main app, it will continue to generate the widget book app for us, which is an app used to showcase the UI kit package and all of the widgets that will be used inside our app. Okay, it created the widget book app, and next it prepares the environment variables with its flavor. It also commits flavor, so you don't need to worry about setting it up manually, and it works out of the box with iOS and Android. And then it will initialize a Melos workspace. So since it is a Monorepo app, I use Melos package to manage the source code. And yep, you can see here it's already running the Melos bootstrap command, and it's going to take a while, so I'll fast forward from here. Okay, so it successfully initialized. Now it is running Melos format, which is a proxy command through Melos that basically run Dart format and Dart fix apply in all of the packages inside this Monorepo. You can see the output here. Okay, and now it successfully generated the skeleton for us, and we will open the generated files inside VS Code. Okay, and here is the code. As you can see here, there is app directory which hosts our main app, and also the widget book app, which basically this folder will hold all your Flutter app related to this project. Imagine you want to create an app like Uber. You will have two applications, two different apps, which is a driver app and also user side of the app. So all of that will be hosted right here. And then we can see also the app here. Already have the Flutter configuration here. And we have the launcher icon flavor. It also includes a splash screen template. I'm using my logo here. You can replace it with your own logo later. And then a launcher icons. And then it also comes with predefined launch configurations for your VS Code. By default, it has 3 different flavor: development, staging, and production. It also comes with the widget book launch. And next, we have the features directory. These features will host all of our app features. Because we use modular approach, all of the feature will be created as a small Flutter or Dart packages inside the feature directory. Imagine in your app, imagine in the case before, in which you want to create an Uber-like app, you will have some of the feature will be the same between this app. For example, you want to create an authentication feature. If you want to create it separately, you will create authentication feature inside the main app and also inside the driver app. And yeah, we will just repeating our code. And by extracting it into a reusable module like this, we can create it once and reuse it in every single one of our application. That's why we create it using a modular approach, so we can import it as a package into our app. And then there is the packages directory, which will host all of our local packages. Here we have 2 packages, core packages, which are the core part of our app. We have base data model right here, and also dependency injection, exception, extension, failures, helpers, loggers, network, etc. And also we have the UIKit package right here. This package is used to implement design system from Figma, and I follow the atomic design approach to create these packages. As you can see here, we separate our widget into a smaller form called atoms, and then molecules and organism, and then templates. But right now, by default, we only have atoms and molecules. We also have tokens, which will store the token from Figma design, like colors, shadow, size, typography, etc. And then there is also the foundation layer. So in the atomic design approach, the atoms layer cannot access value of token directly. So we need to create a bridge between them. Here comes the foundation layer. And then I also utilize theme extension to handle dark and light mode, because sometimes we need to load different color, style, or assets for different brightness mode. For example, we can see here foundation themes. I have 3 extensions. We have asset extension right here, have SVG and Lottie file, and then we have color extension, and then we also have shadow extension. And imagine if you have to do or handle this kind of situation manually. It will be a lot of effort, and by using theme extension, we only need to create some class like this. You can see here I have Lontar SVG class. Then I define the asset right here, the light asset and dark asset. And then by using the extension, I can initialize it inside the theme initializer. Here, for example, in my asset extension, we have Lontar SVG and Lodi. We have a factory builder for light and dark. And then in our main app theme, here is the theme. When we initialize the light theme, we also register the extension right here, the light version. And then when we initialize the dark theme, we also register the dark version of the extension. Okay, we'll try to preview the app, but first thing first, I will try to run a simulator. Okay, here is our simulator. And to run it, we only need to open the run and debug section in our VS Code, select widget book, and then you can press run. It will try to run the widget book app. Okay, the app is up and running. Here is the homepage of the widget book app for the mobile version. Here you can see the button to transition to every single pages. We have foundations, atoms, molecules, organism, and templates. And if you pay close attention to the logo up here, see which kind of logo we use in dark mode. And then when we switch theme to light mode, it also replaces the logo with an appropriate logo right here. That's how powerful extension is. Also, we have the code snippet right here to preview how to use it in our code. Okay, we will go to the foundation layer here first. Here we have border radius. We can preview the size of every single border radius. The code snippet also will be updated based on the selected item. And then we also have the dimension right here from 2 to 72. And then we have the colors. Here is the colors. We utilize theme extension, as you can see here, context.lontara color. And if you pay close attention to these colors, if I change the theme into a light mode, notice how the value changes. Right there. You see, in light mode, the background card main will be a white color. And when we switch to dark mode, it will update it to this color. And then we have shadow. It will be used for card, header, footer, and modal. Here is the light mode, and here is the dark mode. Then we also have atoms right here. There is 4 basic component, comes with this brick by default. We have animations, maintenance, and Wi-Fi. And then we have button. Here, as you can see, we can resize it like this. We also can preview the light mode and dark mode. Okay, then we also have card, and then we have logo. Here, notice how the logo changes. That's how powerful extension is. Because for now we only have foundation and atoms. When you open the molecules, organism, and templates, it's only redirect you to atoms page because we don't have it yet. And you can update it later. And okay, that's for the UI kit package. And we can close it. Okay. Next, we continue exploring our code base right here. After the packages, there is this plugins directory. This will host all of our shared plugins that will be used across the app. Right now, I don't have any plugins. By default, it also doesn't have any plugins. And then we also have custom scripts right here. So these custom scripts I've incorporated is to ensure our development process is not only efficient, but also comprehensive in terms of quality assurance. So we have 3 scripts here. We start off with the test with coverage script. This is a critical tool in our development arsenal. This script doesn't just run our test suite, but it meticulously generates a coverage file for each test and for each packages, ensuring that we have a detailed insight into the test coverage of our application. And then following closely the combined coverage script, what this script does. So the combined coverage script is using to amalgamate the coverage data from all of our packages into a singular alco file, providing us with a unified view of our test coverage landscape. And using this, we have a bird's eye view on our test coverage. This bird's eye view is indispensable for identifying areas in need of attention or improvement. And then lastly, we had generate HTML coverage. So from the combined coverage we created using previous script, by running this script, we then convert the alcov data into a navigable HTML report. For me, this visual representation of our test coverage is instrumental for our team, especially if you're working in a team, because it's offering us an intuitive way to delve into our coverage metrics and drive our commitment to excellence in code quality. Okay, that's in the scripts directory. Next, we transition into our shared directory. This repository houses 3 pivotal shared packages. First things first is dependencies package, which is a consolidated collection of shared dependencies that we use across our app. This package basically just export all of the shared packages. We have autoroute, block, darts, equal Flutter block, phrase annotation, get it, injectable, etc. And by using this dependency, I hope we can streamlining our package management and ensuring consistency across our development project, because we only need to manage all of the package inside one single package. And then we also have shared analysis options for our linter rule here. This will be used inside all of the package right here. If we can see here, for example, analysis option of homepage, it's using the shared analysis options from dependencies. Okay. Why we use it like this? Because by using a single source of truth for our linter rule, in this case I'm using analysis option from our dependencies package, it helps us to set a uniform standard for our coding practices, and also help us reinforcing our dedication to code quality and consistency. And next we have a config package, which emerged as a versatile tool for managing our applications environment and flavors. As you can see here, we have different environment. We have environment for production, development, and staging. So out of the box, we support 3 primary flavors. It also managing our flavors like right here. We have development flavors, staging, and also production. I created it like this to make sure that we are equipped to cater to various stages of the app lifecycle seamlessly. And we also have this flavor class with its flavor status enum, enable us to globally set the app's flavor. For example, if I want to set the flavor status to development, we only set it once during app initialization. For example, here in our main development, we set the flavor status to development. In the staging, we set it to staging, and then in the main, we set it to production. That's for the flavor. And then in terms of environment variable management, I'm using env package because for me, this package is standout for its capability to obfuscate sensitive information. And I think it's significantly enhancing our application security because this approach not only safeguards our environment variables from exposure, but also eliminates the need to include the .env file in our pub/spec YAML, like the flutter.env, for example. As you can see here, I defined 3 different variables for prod, development, and also staging. And here is the generated file. We can see the value is obfuscated. And then I have an utility class here, env, which I use to map all the value of the environment variable based on the flavor status. And for each flavor, we have dedicated environment files, as I said before. And then it will automatically generating corresponding environment classes. And yeah, this class plays a critical role here because it acting as an environment reader. As you can see here, I name it environment reader that will maps all the possible environment values based on the selected flavor. And this helps us streamline the mapping process in how we access critical variable. In this example, we have API-based URL variable. And also, I committed to create an app that can be globally accessible. So it is embedded in this localization package here, which houses our localization efforts. I'm using Slang package as the dependency here. I'm using Slang. And for me, why I'm using Slang? Because we're able to organize our localization file into separate namespaces or features. And I think it enhances the manageability and scalability of our localization strategy. For example, here within the JSON directory, by default, we have 2 different namespaces or features. We have feedback, and we also have general right here. The translation are neatly organized by namespace and language. You can see right here. We have a convenient namespace also, naming convention, that I think simplifies the localization process. You can see here we have feedback and then error. This is the default English, and then this is the Indonesian version. To generate the locale, I'm using Melos generate locale, which is a custom script that I'm using here in my Melos. We'll go deeper in the end of the video. And it will dynamically generating all the necessary localization file and paving the way for an inclusive app experience. We will deep dive into another feature like dependency injection and also routing. For dependency injection within this application, I'm using a dynamic duo in Flutter ecosystem, which is Get It and Injectable. Why I'm using injectable? Because I think injectable streamlines the process of implementing modular dependency injection. Since we're using a modular approach right here, the injectable really help us streamline the process of that, because it facilitating a structured and efficient approach to managing dependencies across various features of our application. For example, we can see here inside our home features, we see inside this DI directory, inside this feature, we have this injector file. It only have a single function like this, injector home module, which we annotate using @microPackage_init annotation. By using this annotation, it's enabling the module-specific dependency injection with finesse. If you see the resulting generated file, here is it. It really fasten our development process, and also by using the generated file here, we can seamlessly integrate it with our main dependency injection architecture. For example, here the main dependency injection is inside our core packages. We see right here we have service locator. Inside this service locator, we have a dependency injection setup using @injectable init. And then this annotation have three different properties. We have external package modules before, and then external package modules after. What is the difference between all of them? So the external package modules before is used to run packages that we need to initialize before we call our core dependency injection or main dependency injection. And then we have external package modules, which is generated or initialize the generated module dependency injection based on the main dependency injection file configuration. By default, I think it's using the order by the name of the file or also the dependence. And then lastly, we have external package module after, which is used to register a module dependency injection module that will be initialized after we initialize our main dependency injection. So because my home package module need some dependency injection from our main module first before it initialized, that's why I pass it right here to make sure that all of the core dependency injection is initialized before we initialize our module. By default, when we use the external package module, we have without after or before, it will typically following an alphabetical order or dependency based order. Maybe for an in-depth understanding, I recommend you to exploring the detailed documentation of these packages. It will give you much more information about how powerful injectable is. And then for the routing, I'm using auto-route packages. Why I'm using auto-route? Because I think this package doesn't just streamline the routing within our Flutter app, it also revolutionizes it by allowing us to create the separation of routing logic for each feature or module. As we can see here again in home, we have router right here, and we have home router, which we annotate with autorouterconfig.module. This annotation enabled us to create a modular based routing. And then autoroute, we generate specific route to this module. Here is the generated file. Then we can use this generated routing in our main app, our main route right here, by adding it into our auto-router config annotation in our main module. This annotation have modules property, which receive a list of router config from our modules. Here we register our home router modules. I think this is really help us enabling a highly organized and modular routing structure. That's why I'm using AutoRoute, because AutoRoute's capabilities position it as a top tier, I think, as a top tier in routing library within the Flutter ecosystem, and its documentation is a treasure. You can learn more about it in the documentation. And to bring it all together and manage our Monorepo, we turn to Melos. This is the tool that is nothing short of a cornerstone of our project, providing a robust framework for managing the Monorepo's complexities within the Monorepo itself. As you can see here, inside our Melos configuration, which is a melos.yaml file, we define our configuration. We give it a name, and then we include all of the packages to be mapped by this Melos. We also have command right here, bootstrap. We include this part that will be shared across all of the packages inside here. So whenever we run Melos bootstrap, all of the dev dependencies across all of these packages will be updated using this value. And then we have hooks right here. Hooks, it has pre and post hooks. Pre to run or execute a script before bootstrap executed, and post is to execute the script after the bootstrap is executed. Here, after run the bootstrap command, we will run this script, Melos run initialize app. We also have clean, Melos clean, to run Flutter clean command in all of our packages, and also to run build runner clean. There are so many more custom script I created here, like generate widget book, generate core, generate localization, generate asset, etc. Here, initialize app, that will be run after bootstrap command. Basically, this is the central place to create a custom script that you can run across your packages. There you have it. There is the comprehensive walkthrough of my brick, which help us generate a skeleton of Flutter app. We also see how it utilizes some of the best packages out there. Also, through the combined powers of Get It and Injectable, AutoRoute, and Melos, we laid a foundation that not only streamlined the development process, but also, I think, set the stage for creating a scalability and maintainability for our application. And as we wrap up today's journey, I hope you found these insight and strategies enlightening. Because by seeing this breakdown, we can see that the beauty of Flutter lies not just in its ability to create stunning apps, but also in the vibrant ecosystem of tools and packages created by our community that empower developers to build with efficiency, structure, and foresight. And I think whether you're fine-tuning an existing project or embarking on a new Flutter venture, I encourage you to explore these tools further. And you can start by diving into their documentation, experiment with their features, and discover how they can transform your development workflow. And lastly, thank you for joining me in exploring this architectural deep of my Flutter brick or Flutter project here. Our passion to learn and innovate really drives this Flutter community forward, I think. And if you find this video helpful, consider like, sharing, and subscribe for more content like this for me. And as always, feel free to share your thought, question, or experience in the comment below or on social media, and let's together create a learning environment for our community. And okay, before we sign off, I also want to hear from you. Let me know your opinion in the comment section below. Whether should I publish this package into BrickHub and make it open source, or do you think there's a better way to approach this? Your feedback is invaluable, and based on your suggestion, I will also strive to create a comprehensive documentation page to help you get started using this brick. I already have some of the documentation in each of these package like this with me in our UI kit. It's still empty, I think. Yeah, I'm not filling it up yet. But in some of this shared dependency, we are already filling up the documentation like this. In case you need to know about this, how to get started. But yeah, I will try to create a comprehensive documentation page to help you get started using this brick. And until next time, happy coding.